Good morning. So today what we are going to do is go over the comprehensive test. You will see that it wasn't a very difficult test. It was pretty simple, nothing too challenging. This was a 90-minute paper, just like all the other tests you have written before. It was out of 50 marks as usual. So whenever you start the tests, please make sure you go through the instructions. Maybe it's something that you're not aware of, and just relax, breathe. It's gonna be fine. None of the tests we've written have been difficult or very complex. Most of the questions, as you have seen, you've seen them before, and a lot of you did very well in the tests. So there is no reason why even in this supplementary test you should not be able to pass. Okay, so let's just quickly get into it. As always, we have a multiple choice section. We will go through all of these. Now, as I'm going through this, I will be switching back and forth with the multiple choice or reading the question and then writing down some my working if needs be. But with the multiple choice, there isn't very much that we need to calculate. Okay, with question 1, for the results of a parametric statistical test to be valid, the data should be A, not show homogeneity of variance, B, measurements on a categorical scale, show homoscedasticity, B, roughly normally distributed. So all this time we have been talking about your data must be normally distributed. So when you see things that are odd, you've never seen them before, go with what you know. The correct answer is D. So 1.1. The answer is D. And 1.2, there is a type 2 error is when one rejects the null hypothesis when it is in fact true, if one accepts the null hypothesis when it is false, is always the result of a bias in the sample error of using the test. So it's not C or D, because type 1 and type 2 errors involve rejecting or failing to reject a null hypothesis, depending on whether it is true or not. Okay, so a type 1 error occurs when you reject a null hypothesis that is true, and a type 2 error occurs when you fail to reject a null hypothesis that is false. So that means you're accepting a null hypothesis that is false. So our answer to 1.2 is B. Then 1.3. 1.3 says, if a sample is unrepresentative, what does that mean? That is it A, that there's not enough data, that not enough data was collected, B, that the data is not normally distributed, C, that one single measurement was not typical and therefore not useful, and D, that this sample should not be used to make inferences about the population. So you always read through your options and then pick the one that is most correct. So if we're being told that our sample is unrepresentative, let's say, for example, you're doing a study about men, and then your sample is 90% female, that is obviously not representative of the population, so you cannot make any inferences on that. So just because 90% of women, yes, they like that That does not mean you go and say 90% of men like my product. So that would not be correct. So what the correct answer would be D, that the sample should not be used to make any inferences about the population. This is D. Then 1.4. If you perform a one-tailed statistical test, your hypothesis is A, that the experiment was conducted double-blind, B, that the difference between your groups will be in a specific location, a direction rather, the two different measurements are unpredictable from each other, that the variance of two measurements does not differ significantly. Now the answer is B. The reason is a one-tailed test. Those are example where you say the mean is less than a specific amount, but it's greater than. So it is in a specific direction, as opposed to when you just say is not equal to or is equal to. So the one-tailed test is in a specific direction. You're going to be less than or greater than. So 1.4, our answer is B. Then 1.5. What is a standard deviation of a sampling distribution called? Is it a sampling error, a sample error, standard error, simple error? So again, this is one of the things that we should know, that the answer is a standard error. So 1.5, the answer is C. So that's a definition. Definition of the standard error is that it is the standard deviation of a sampling distribution. So 1.5 is C. 1.6, as the sample size goes up, what tends to happen to a 95% confidence interval? So remember, usually we like our samples to be as big as possible, but that's not always possible because we talked about this when we're doing sampling. Sometimes it's expensive to have a very big sample. For example, if you're testing airbags in a car, what pressure of impact will cause the airbag to go off. If you're going to test that on all your cars, at the end of the day, you won't have any cars left. So that will be very expensive. But usually we like our sample to be bigger because, is it A, it becomes more precise? Yes, it does actually become more precise. B, the confidence interval becomes narrower. These two are actually similar, because if your sample is narrower, so if I say, for example, I'm thinking of a number between 1 and 100, your chances of getting the number I'm thinking of is pretty low. Unlike if I say I'm thinking of a number between 50 and 60, your chances of getting the right number that I'm thinking of is much higher. So here we see that A and B are pretty similar. It becomes wider. No, if your confidence interval is very wide, then it's not a very good estimation. And both A and B, which is the correct answer. So it does become more precise because as the sample size goes up, you get closer to the population, and it does become narrower because it is becoming more precise. So the answer 1.6 is D. Okay, then 1.7. For 1.7, the null and the alternative hypothesis divide all possibilities. Is it A, two sets that overlap? No, it is not possible for the null and the alternative hypotheses to both be correct. Two non-overlapping sets, yes, so this is our first candidate. Let's read. Two sets that may or may not overlap. There is no possibility at all that they may overlap, so that's not right. As many sets as necessary to cover all possibilities. No, this is not right. Because there are only two possibilities. Either the null hypothesis is correct or the alternative is correct. So it's not as many as necessary, it's just the two of them. So the most correct answer is B, and you must always pick the most correct one. 1.8. When a researcher fails to reject a null hypothesis, dash error occurs. Okay, so when you fail to reject a false null hypothesis, remember type 1 error, sorry, let me go through the options. Type 1 error, a non-sampling error, a type 2 error, or a sampling error. Non-sampling and sampling errors, these are to do with the sample itself. So maybe you were biased in your picking or some other type of error. So those have to do with the sample, not necessarily with what the researcher concludes. Now we know that a type 1 error occurs when you reject a null hypothesis that is true, and a type 2 error is when you fail to reject a null hypothesis that is in fact correct. So we are failing to reject a false null hypothesis that is a type 2 error. So this is similar to which question? This one, 1.2. So 1.8, the answer is C. 1.9. 1.9 dash is the difference between a sample statistic and the corresponding population parameter. Is it a standard error? I think the standard error, we already defined it in 1.5. And is it a sampling error? Is it a difference error? Is it a type 1 error? So we know it's not a standard error. We defined it above. It's not a type 1 error. We defined it in the previous question. Not a difference error, it is actually a sampling error, because this has to do with the sample. So your sample does not give you the actual value in the population. So that difference comes because of the sample that you picked. So each sample that you pick will give its own sampling error. So 1.9, the answer is B. Then 1.10. 1.10, a student calculates a 90% confidence interval for population mean when population standard deviation sigma is unknown and n is equal to 9. The confidence interval is minus 24.3 cents to 64.2 cents. The sample mean is. Now, something we should say is, if this is your confidence interval, your sample mean is exactly between the lower bound and the upper bound. So you're looking for the number that is exactly halfway between these two numbers. So to get the answer, what you'll need to do is add these two together and then divide by 2. So let's do the calculation and then we'll come and see which of our options is in fact correct. So we have minus, I will just do it over here. Let me do it in red. So it's minus 24.3, and then we add 64.3, and then we divide by 2. So again, my calculator, negative 24.3 plus 64.3. Okay, this gives me 40 over 2, and this is equal to 20. So we go back to, let me just label this, this is 1.10. Okay, so we go back to the question, 20 over here, it's option D. So the correct answer is D. Okay, so that's the multiple choice. Again, very simple, nothing too complicated. Always pick the most correct answer. All right, so for each of these, there is 2 marks available. So 2, like that. So you either get 2 marks or 0. Okay, then let's look at question 2.1. Question 2.1 says a consumer group concerned about the mean fat content of a certain grade of beef burgers submits to an independent laboratory a random sample of 12 beef burgers for analysis. The percentage of fat in each of the burgers is as follows. So these are the percentages that the lab got from the 12 beef patties. The manufacturer claims that the mean fat content of this grade of beef burger is less than 20. So the manufacturer makes a claim that it's less than 20. You should take note of that. Now assume the percentage fat content to be normally distributed, and then you answer these 3 questions that follow. Number 1, 1.1, compute the population mean estimate for the fat content. So calculate the mean, and we know how to do that. You add each of these terms, you add them all together and then divide by 12 because there's 12 elements. So let's do that. This is 2.1.1 x bar. This is equal to the sum of all the x's divided by n. The sum of all the x's, this is 228 divided by 12, and this is equal to 19. Okay, now in the allocation of marks, just so that you know your working is important, the formula gets a mark, and then the answer, you get a mark. And the next question, 2.1.2, compute a 95% confidence interval for the population mean estimate of beef burger. Okay, so we need to construct a 95% confidence interval. Here you just need to recall your formula for calculating the confidence interval. And the formula is as follows. This is 2.1.2. So our formula for the confidence interval, this is x bar plus or minus. Sometimes we use Z, sometimes we use T. Here we use T. Here with the paper that was given, there was only a T table provided, so that should be your first hint that there's no way they would ask me to have a Z here if I'm only provided with a T table. And another thing is it's the size. The size of the sample is small, and the population mean is not known, it is unknown. So if you remember the flow chart that I asked, first question is sigma known? If sigma is known, then use the Z or the Z table. So here we are told that sigma is, well, we're not told what sigma is, but it's not given to us, so it is unknown. And then the second thing is you look at the sample. If the sample is more than 30, you use the Z. If it's less than 30, then you use the T. Here we don't have sigma, we have a small sample, so this is a T. Okay, so this is the T, and then we will have alpha over 2, then the degrees of freedom is n minus 1, and this we will multiply it by sigma over the square root of n. So this is how we will calculate our confidence interval. Now x bar, the mean, we already calculated it in 2.1, so we'll just substitute this T alpha over 2. So let's do our sub calculations over here. T alpha over 2 90 n minus 1. So remember, we are asked to do 95% confidence interval. So this means that alpha is equal to 0.05. So here we are looking for T 0.05 divided by 2, and then 12 minus 1. This is T of 0.025, comma 11. So this is what we are going to read from our table. So let us go to our T table. Okay, so here are T values: 0.4, 0.25, 10, 0, 0.5, 0.25. So this is the column that we are interested in. And then the degrees of freedom are 11. So our T value is this, 2.20099. This is 2.20099. And then the only other thing left is our standard deviation. So we know how to work out the standard deviation. We have the standard deviation is given by this big square root of the sum of the squares of all the individual elements minus the square of the sums divided by the number of elements you have. This is all divided by n minus 1. So here what you do is you square each of the elements. So with your entries, you'll 21 squared plus 18 squared plus 19 squared plus that, and so on. And then this is just 228 squared, and then we know what n is. So let's work this out. This is the square root. The sum of the squares, this is 4448 minus 228 squared divided by n, which is 12, and this is divided by 11, which is n minus 1. So this you do on your calculator. When I did it, I got a 3.247376564, and I approximated to 3.2474. Okay, so that is my standard deviation. Now going back to my formula, now I have everything. I know what x bar, I calculated it over there. I know what the t value is, what s is, what square root of n is. I can now form my confidence interval. Okay, so I will say 19 plus or minus 2.20099 multiplied by 3.2474 divided by the square root of 12. So this gave me 19 plus or minus 2.0633. Okay, and then as always, write a conclusion. Say we are 95% confident that the true population, okay, I'm shortening that, maybe not, true population mean fat content lies in the interval from 16.9367% to 21.0633%. Okay, so that's how you would do the question. Now let's look at how the marks are allocated. Okay, this question, let me see. This was worth 5 marks. Okay, so you can write it a little bit differently, but everything should be worked out. Everything should show. So it might not be in the same order that I have done it, but I must be able to see everything. So the first mark is for the formula. So this formula here, I wrote it right at the top, so I'll give you a mark for that, or you get a mark for that. Then the second is for the substitution. Where did I do the substitution? Okay, so the t statistic and the standard deviation, and then the last one is for the endpoints, like that. So that is your 5 marks. Then we look at the next question, 2.1.3. Okay, carry out an appropriate hypothesis test at 5% level or at 5% level in order to advise the consumer group as to the validity of the manufacturer's claim. Okay, so here we're doing a statistical test. You'll need your alternative hypothesis. You need your test statistic, your decision rule, make a decision, conclude. Okay, so remember those 5 steps. So let us get into it. So H naught, we have that mu is greater than or equal to 20, and our alternative is that mu is less than 20. Now remember, your alternative goes hand in hand with the claim that the manufacturer was making. So if you look at the question or the information that was given, it says the manufacturer claims that the mean fat content of his grade of beef burger is less than 20%. So his claim that it is less than 20% is what the alternative hypothesis should say. So this is the claim that it is less than 20. So that's how you know which one should I put less than here, or should it be greater than. So first you make your alternative, which is in line with the claim that the manufacturer is making, and then the opposite of that is your null hypothesis. Okay, so that's the first step. We have the claim, or sorry, our hypothesis. Then the next thing is our test statistic. So this was step 1. Step 2 is our test statistic. So here we use T stat. This is given by x bar minus mu over S over square root of n. And we have all of these. So we just substitute. This is 19 minus 20 over 3.2474 over the square root of 12. And this is equal to negative 1.066730805. Okay, so I approximated to 1.0667. So this is my test statistic. So again, it's a T statistic because when I was coming up with the confidence interval, I used the T table. I do not even have a Z table, even though the way I calculate them would be the same, but it is a T statistic. Then the third step rather is our decision rule. Our decision rule is step number 3. Now the decision rule, we know that alpha is 0.05. This is a one-tailed test. So you know our T table looks like that. So it's a one-tailed on the left. So this is our rejection region. That's our rejection region. Okay, and this area must be equal to 0.05. So what we do is we look for t of 0.05 and 11 degrees of freedom, and because it's on the right of 0, we'll make it negative. Okay, so let's go to our table. So here we have 0.05 and we have 11 degrees of freedom. So this is the one we're looking for. Okay, 1.795885, but it's negative because it's on the left. So this is negative 1.795885. Okay, and then our rule is that we reject H naught if our P-stat, or the calculated, is less than negative 1.79588. Sorry. Okay. Let me write this better. 79585. So this is our rule that will help us determine whether we reject or fail to reject the null hypothesis. Okay, so next thing is our decision. Okay, so with the decision, we now decide, should we reject H naught or should we fail to reject? So we look at our T of our T-stat, or T calculated. This is equal to, we calculated it over here, this is negative 1.0667. And this is in fact greater than negative 1.795885. So we fail to reject H naught. Okay, so we fail to reject H naught. Now we make a conclusion. Okay, so we conclude with 95% confidence that there is not enough evidence to support the manufacturer's claim that the percentage of fat content is less than 20%. Okay, so that is how our conclusion. So remember, your conclusion should be in line with what you said in the previous step. So over here, if you fail to reject H naught, just going back, remember what H naught says, it's greater than or equal to 20. So you're rejecting the alternative, it's not less than. So that's what the null hypothesis is saying. So there is not enough evidence to support the manufacturer's claim. And that is how you should answer the question. And then look at how the marks are awarded. So this question, let's see, 2.1.3, it carried 8 marks. So let's see how the 8 marks are distributed. So we have a mark for the 2 hypotheses, then the t-stat, the formula, the actual value. Then there is a mark for the t that you get from the table. And then we get a mark for our decision. That means we failed to reject. So I'll look for that. We failed to reject. That's another mark. And then your conclusion, I want to see that you're 95% confident or 5% level of significance. And I want to see that you do not support the manufacturer's claim, or the sentence that you write must be in line with you failing to reject the null hypothesis. So if you count the marks, is 1, 2, 3, 4, 5, 6, 7, 8. Yes, so those are your 8 marks. Okay, then the next question. Point 2. So 2.2, 500 elementary school learners are asked which their favorite color is. Was it blue, green, or pink? And the results are summarized in the table below. At 5% level of significance, is there evidence that there is a relationship between gender and favorite color? So I'm sure even when you think about this, you must have an inkling. And when you do the calculations, you would expect it to follow or in line with what you're thinking. So this is elementary school, maybe primary school and lower. Those children do have so those children do have a preference. You'll see most of the girls are wearing pink. Most of the boys like blue, so here we would expect that there is a relationship between gender and favorite color. Okay, so let us do the working to see if what we have is, well, what we're thinking is in fact correct. Okay, so we know how to do this. We need to come up with a table, show the observed, then the expected, and then from there we will work out our test statistic. So whenever we're carrying out a hypothesis test, we follow the 5 steps. So first one is our H0, then we have our alternative. Now the H0 always says there's no relationship. So the H0 is always no, they're independent, there is no relationship. So our H0 is there is no relationship. So when you're writing this, please write the full word. There is no relationship between gender and favorite color. And then the alternative is obviously just the opposite of that, which is there is a relationship between gender and favorite color. Okay, yeah, favorite color. So that's step number 1. You state your hypotheses. Then step number 2 is you find your test statistic. So to do that, this table over here, I'm going to rewrite it. So I have a column of observed and expected, and then I will work out my test statistic. So I need more space for that. Okay, so I'll start with my observed, which is the O. I have my expected, and before that, let me redraw this table. Okay, so I have boys here, I have girls here. I just want to include the totals. I have blue, green, pink, and I'm extending the table to show the totals. Okay, so here I have 100, 20, 120, 150, 30, 80, 20, 180, 200, 270, 230, 500. Okay, now the way we work out the expected is, if for example I want to work out the expected value of 100, I just multiply the row total with the column total, with the row total. So I'll say 120 times 270 and then divide by 500. So the expected value of this 100 over here, you say 120 multiplied by 270 divided by 500, which gives us 64.8. So now I can work this out. So I'm going across the row first. So I start with the observed values of the boys. So I have 100, I have 150, I have 200, and then the observed for the girls, I have 20, 30, and 180. So my line here is big. Okay, then we look at the expected values. So again, row total times column total divided by the grand total. What I got here is 64.8, 97.2, 108, 55.2, 82.8, 92. And then what we do is we work out O. Let me shift my table down. We work out the observed minus the expected. You square this and then divide by the expected. So that is what we'll have there. So 100 minus 64.8, you get an answer, you square it, and then you divide by 64.8. So I got 19.
You out of class?
I'm in class.
Why would you mute it?
Okay, sorry about that. Then this is 19.12099, and I have 28.68148, 71.7037, 22.44, 638, and then 33.66957, 84.17391. Okay, and then now to work out our test statistic. So this is a chi-squared test for association. So this is just equal to the sum of the observed minus the expected squared over the expected. So what this means is you just add up all these terms together and then you get your answer. So when I did it, I got 259.79603. Okay, so that was step number 2. So step number 2 with the chi-square test for association, that is usually the longest step because of all these many calculations. But once you get through it, everything else is the same. So step number 1 was your hypotheses. Step number 2, your test statistic. Step number 3 is your decision rule. So the rule, we have the chi-square value that we need to read from the table. Here we have 0.05, and our degrees of freedom we need to calculate. Then we say it's row minus 1 multiplied by column minus 1. So how many rows do you have? Subtract 1. How many columns do you have? Subtract 1, and then multiply the 2. That will give you the degrees of freedom. So what we're looking for is chi-square of 0.05. And here are my degrees of freedom. Rows, I have 2 rows, boys and girls, and I have 3 columns for the colors. So the 2 rows, we have 1, 2, and my columns, I have 1, 2, 3. So 2 minus 1 is 1, and then columns, 3 minus 1 is 2. So 1 times 2 is 2. So my degrees of freedom are going to be 2. Okay, and then this I get from my table. So you go to your chi-square table. This is your chi-square table. You look for 0.05, which is this column, and then you look for 2 degrees of freedom. That is the chi-square value. Okay, 5.99146. 5.99146. Okay, and then the rule is going to be that we reject H naught if our value is greater than. Reject H naught if the chi-square that we calculated is greater than 5.99146. It doesn't fit there, but you should write it. Now that we have our decision rule, you make your decision. And the decision here is very simple. Our calculated value was 259, which is obviously greater than 5.99. So we will reject H naught. So we say that since our chi-squared that we calculated, or the statistic 1, 259.79603 is greater than 5.99146, we reject H naught. And then you make a conclusion. Now your conclusion is just stating in words the decision that you have made. So we reject H naught. What does that mean, and at what level of significance? So we say we are 95% confident there is in fact an association. There is a relationship between gender and favorite color in elementary school. So again, you can word it a little bit differently, but the message should be the same. So that is concluded. Let's look at how the marks are allocated. So this was question 2.2. It was worth 10 marks. So we did a little bit more work than 2.13, so that makes sense. So let's see how the marks were allocated. Okay, so the first 2 marks was for your null and alternative hypothesis. Your null should say that there is no relationship. So this is what I will be looking for. There is no relationship. And your alternative should say the opposite of that. That means there is a relationship, there is an association. So here you can also use the word independent. Gender and favorite color are independent. Then your alternative is that gender and favorite color are not independent, or they are dependent, something like that. Okay, and then the next marks is, so there's 4 marks here. There was 1, 2, 3, 4, but 4 marks. Then our chi-square value, which is the 59, is a mark for that. And then a mark for the reading from the table, which is 5.99146. And then your decision, that we reject H naught. Okay, I didn't write it, or I didn't finish writing. We reject H naught. So there is a mark for that. And then your conclusion, again, what I want to see, and we want to see 95% confidence and that there is a relationship. So the things that I will look for. So both of them must be there. Now let's count the marks. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is all the marks that come with the question. And then the last question, again, not very difficult. So let's do that one. This is 2.3. Let's look at the question itself. Now 2.3 says the following data shows the value of exports of fish and fish products in millions of Namibian dollars for a local company. This is the year, and that's how much they exported. Then we have to find the 3-point moving average. So this 3-point moving average just means take averages of 3 data points at a time. So nothing too complicated. So we'll have to form a table. So I have year, 2008, 2009, 2010. Okay, then I will have the shipments. And then I have the 3-point moving average that I will work out. So first I have 510.3, 542.4, 547.8, 563.5, 560.2, 578.1, 569.2. Right, now the way we work out the 3-point moving average is we take 3 points at a time and then the average goes right in the middle. So if I take the first 3, the average will go right there. The next 3, the average will go there, and then all the way till the end. So the first one will not have an average, so we'll put a dash over there. Then for the next one, I say 110.3 plus 42.4 plus 547.8. You add them together, divide by 3, you should get 533.5. Then I have 551.2333. So this one, I said 542.4 plus 547.8 plus 535.5 and then divided by 3. Then I do the same thing with the next one, this plus this divided by 3. My answer goes over there. This is 557.1667. Then the next one, we have this one, that one, and that one. Answer will go over here. So it's 567.2667. Then the next one, this plus this goes here. 569.1667, and then the last one does not have a point because you don't have a value over here. So that is how you calculate the 3-point moving average. So it's just averaging 3 items at a time, and the average you get goes in the middle year. So there's 3 of them, 2008, 2009, 2010. The middle year is 2009. So this question, very simple, was worth 5 marks, and each of our answers got a mark. So 1, 2, 3, 4, 5. And just like that, it's 100%. So you can see this has not even been an hour where I have gone through all the questions. So 90 minutes is plenty of time to work on the paper. So again, when you get to the exam, just relax. Make sure you have studied, you remember the things that you have done. Don't panic. If you're done early, don't just get up and go. Check what you have done to make sure that you have done it correctly. Okay.